welcome to today's video. I'm Ed from Men's Hobs and Interests. So the other day I was lying down in bed and I've got a skylight window, which basically means I can look out the window as I lie down in bed and I can see all the stars. And I was thinking, you know what, I would really like to buy a telescope, but I don't know the first thing about telescopes. So I decided I would go on YouTube and I'll do some investigations, and I came across this guy who basically made his own telescope, his reflective telescope. I think it's called a Newtonian telescope. Now, I didn't know anything about telescopes, so I started watching this video and it was super cool. It was really good. The guy was really good. It was presented really well. So anyway, I thought, you know what, I'm gonna do this. I think I could do this. I think I could build my own telescope. So anyway, I went out and I bought all the parts that I need, and in this video I'm going to basically introduce the subject. I'm going to talk about how to find the focal point, or sorry, the focal length of the actual telescope, and all the parts that I bought. So I'm going to be using this tube which I made. This is a 1 meter long tube. It's just over 10 inches in diameter, but the actual mirror I'm going to use is 8 inches. But I need space within the mirror just to make all the brackets that's going to hold the back mirror in position, the primary mirror. So I'm going to show you how I made this tube. It started off as a cardboard postal tube, and I basically reinforced it with fiberglass cloth and resin. So I'll talk about that. I basically bought this mount, I don't know if you can see very well. I think this is called an equatorial mount or something like that. This came from a Celestron EQ 114 or 115 or something like that. And I also got my focuser, which is a 2-inch focuser. Now this came from China and it wasn't casted very well, so I had to put it through my milling machine and basically flatten it out just to make it sit. It'll do for, you know, a DIY job, so it's okay. I fixed it, it's good. I've got some lenses which I'm going to use. This one's a 40mm lens. Now what the lens in a telescope, from what I understand, the lens basically magnifies the image, so you'll end up with a small image and this will magnify it. Also got a 26mm lens and a zoom lens. Now this is like 6 lenses in one, so you got 7, 9, 12, 16 and 21. So this will save me a little bit of money rather than buying all these lenses, because I don't know anything about astronomy. I'm just starting off, so I weren't sure what lens to buy, so I just went ahead and I bought this. It's going to have an adapter, so it's going to go from 1.25 inches to 2 inches. The mirror that I'm going to use is an 8-inch. It's 203mm, and the focal point was advertised as 800, but I measured it, and I'll show you how I measured it later on, but it came out at 750mm, the actual focal point, so it's a little bit shorter. But the downside to that is that you're going to have a telescope which doesn't have as much magnification. On the plus side, because it's shorter, you're going to basically have an image which is a lot wider and it's going to gather much more light, so it will be better for astrophotography from what I understand. But you know, once the telescope is built, we'll know for sure. So stay tuned, and I'm going to start showing you guys how I made this telescope. I'm going to probably start off with the spider first of all. The spider is the section that holds a secondary mirror inside the front of the telescope, yeah, where the eyepiece will go. But I'll show you how I make that and the measurements and stuff later on. Okay, so stay tuned. Hi guys, let me quickly explain how this Newtonian telescope that I'm going to build works. So essentially you have a tube which gathers light, and within the tube you have a parabolic mirror, and the mirror reflects the light back to a secondary mirror. Okay, and the secondary mirror will then bend the light in a 45 degrees. This is the mirror, and it reflects the light back up into your eyepiece. Okay. Now, what would normally happen if you didn't have this mirror here, okay, you'd have this primary mirror at the back, which is a parabolic mirror, meaning it's slightly curved. So it actually, light would come flowing in and then get shot back out to what's called a focal point. Okay, but where you've introduced a mirror now, it gets fired back up into this eyepiece. Now, it's important to know what the length of the focal point is in the mirror. In my particular case, it's 750 millimeters. Okay. The reason why this is important is because you got to know where to put your eyepiece on the tube. Okay, so for example, my tube is 250 millimeters in diameter. Okay, and half of 255 millimeters is going to be 125 millimeters. So you got your 750 minus off 125 millimeters, which is the radius of a 250 millimeter diameter tube, which is basically 10 inches. And then you got to measure the actual viewing plane, the height of your viewing plane of your eyepiece, which in my case is going to be about, I think it's about 3 inches. Let's have a look. 80. Yeah, 80 millimeters, which is just over 3 inches. So you're going to minus off 80. Millimeters, which is going to give you, let me get my calculator out. My mental arithmetic is horrible in situations like this. 750 minus off the 125 minus off the 80, 554. So the eyepiece needs to be exactly 554 millimeters back from the 554 millimeters away from the primary mirror. And I'll explain why that is. So you know you had your focal point of the mirror, and it extended out past the telescope by 750 millimeters. Well, when you put this mirror in, it flicks it round. Okay, so because it flicks it round, it now goes that portion up through your eyepiece. So then you're going to need to put that eyepiece somewhere along this tube. So you got to do this calculation to figure out exactly where you're going to put this eyepiece in the actual tube. So I think it works out. Let's have a look. So 750 okay, so you got 125 here, then you take off another 80, so we're gonna go 125 plus 10, 20, 30, 40, 50, 60, 70, 80. So it's about 8 inches back, and that's exactly where you would put it on your tube, your eyepiece. So I hope that helped you guys out and it explains how the actual telescope works. You know, if you've got any questions or anything, just put them onto the link below and I'll be happy to help. Or if you've got any suggestions that will help me, I would appreciate that too. Thanks. We're going to do the telescope tube today, and what I'm going to use is a postal tube. You can buy these online. This is a 10-inch one, which is 250 millimeters. The wall thickness is 3 millimeters. And the good thing about this particular cardboard is that it's not got that shiny material. It's matte. Basically, you could just paint over it with the fiberglass and the fiberglass should sink straight into it. It hasn't got a plastic coating on it like some of the other tubes that you could get. If you do a Google and you basically type in type in postal tubes, you should be able to find something like this. So this is what I'm going to use. I'm going to actually fiberglass it. I'm going to go over it with heavyweight. It's called fiberglass cloth, and you can find these on eBay. This one's 125 gram, and it's 5 meters by 1 meter. So what I'm going to do is basically wrap this tube up with fiberglass cloth. I'm going to use heavyweight first of all, and then I'm going to go over it with a 91 gram cloth, purely because this will leave a nicer surface finish. Once I've done that, I'm going to actually go over it with something called pill ply. And what happens when you use pill ply, it will give a smooth surface, so you don't have to rub it down too much. Otherwise, if you use normal fiberglass, even though it's nice and strong and it will last, you'll end up with a rough surface, and you'll have to sandpaper it down and spend a lot of time preparing the surface before you can paint it. I haven't decided yet if I'm going to paint the tube or not, but I'm going to finish it off with fiberglass first and see how it finishes, and if I like, I might just leave it plain, but if not, I'll probably do it black or metallic red or something like that, but we'll see how I'll get on. For the fiberglass, I'm using general purpose resin. This is a 1 kilo. I might need more, I don't know. I'm just going to see how I get on. And the good thing with this kit, which I got from eBay also, is that it comes with a hardener and a syringe. And basically you mix 1 to 2% depending on the temperature per volume of resin. So if you weigh this up and it's 100 grams, you would put like 1 or 2 grams of hardener in and mix it. And you just do it by weight, so you've got to have a scale. So I'm going to set this up, and then I'll put the camera on, and then give you guys some tips and see how we get on. Alright, so we're going to prepare the fiberglass resin that's going to go in the tube. I'm going to mix up about 150 grams, maybe 500 grams of resin and 2% hardener, because it's not very hot at the moment. Actually 1% hardener will probably do. So let's get 500 grams, half a kilogram of resin into the container. It's about 532 grams of resin there. So we've got 532 times by 0.01 for 1%. It's going to come up at 5.32 grams of hardener that we need. So let's extract that with the syringe and zero that off. So that's the weight of the syringe. We need 5 grams of hardener in the syringe now. And look, the syringe is not heavy enough. Okay. That's what we're going to do now. That's 5 grams already. So we're going to mix that up. As it mixes, it changes colour as well. When I first go over this tube with this resin, I'm going to go on quite thick because I want to wet the tube up so then I can stick the actual fiberglass cloth on, and I'll film it as I do it. Now I've got to admit, this isn't my technique. I watched it off of YouTube, off of a guy who uses the same technique to make rockets, believe it or not, like model rockets. So I thought I could use the same technique to reinforce a cardboard tube. I'm going to probably end up putting about 6 or 7 layers of this carbon fiberglass onto the actual cardboard, and then 5 or 6 layers of fiberglass on the cardboard tube. Okay, so before I start, I'm going to actually put a marker on the tube underneath it like this, so basically as I start going over it, I can find out each time I've done a layer, so I know when I've done an actual layer. So I'm going to start wetting up the tube. Quite generous with it. Gotta go quite thick because don't forget it's going to suck it up, the cardboard's going to suck up the actual resin. And it's also got to be thick enough to for the fiberglass cloth to actually stick onto it. So if you do it too thin, it's not going to work. And you can see as it sucks it up, it actually changes colour too. It's important when you do this to do it outside or in a well ventilated area, because you know this stuff will get you high. Probably best to start from the middle and spread it out. Now, when you put the fiberglass resin on the tube, it's going to strengthen it up a lot more, so it should last. I actually got this idea from someone else who's actually making a telescope as well, with a tube used for cement forming. He used fiberglass mat though, and these are rough surface. I wanted something a little bit more smoother, so I've done a lot of research and came across the guy who done the rockets, and I liked his approach a little bit more. So that's the method that I'm going to use. Let's see how I get on. You can see how the tube changes colour as it sucks up the fiberglass resin. I'm hoping the tube doesn't change shape once it starts to cure. That's the only thing. Alright, so I'm going to start putting this cloth on now. Let's see how we get on. Doesn't go to the edges. The guy on the YouTube video said to just use the brush to put it through them. Don't know if you can see how I'm dragging the creases out with the brush, so it's ending up nice and flat. It's giving me a bit of problems basically getting it straight because it keeps moving around on the rope. It would be nice if you have a flat base, but you've got to do what you've got to do. They come out anyway, you just flatten them out with a brush, push them out, stretch the cloth over. You can see I've already started, well, you can't see from the camera, but I can see that I've just started on my second layer. Yeah, if you drop a brush, can't use it, it's picked up the shit. So I went ahead and put the pill ply onto the tube after I fiberglassed it, and it hasn't come out too bad. I was gonna actually film putting on the pill ply, but ended up getting all resin on my hands, and you know, my hands were really sticky, so I just went ahead and put it on there off cam, off video. But it's not too bad. You know, it's got some high spots that need rubbing down, but for my first attempt, I think that's the thing I'm thinking of though, is what I could do to protect these edges in the future. I was gonna paint over it with some resin, but ideally what I'd like is some sort of edge that goes over it. So I'm trying to figure out, you know, what I could use for that. Maybe I'll make something up out of carbon fiber or something. Like have a white tube with carbon fiber edges to protect the edge. I don't know, we're gonna see. As I said, this is the first telescope that I've ever made. I don't know if it's gonna work, I don't know if I'm gonna mess it up, but it's gonna be fun making it. It's funny here, you can see the actual edge where I ended up cutting it. It's not very straight because the wind was blowing as I was cutting it, but you know, you're not going to notice that once it's sandpapered down. And I might probably use some, you know, some thick primer, spray it with a couple of coats of primer and then rub it down. You won't be able to see that once it's painted over. It's not too bad. on the next video I'll probably end up making the primary mirror and the secondary mirror sections. So I'll show you how I'm going to do that. Just got to wait for the parts to arrive first. Alright, see you on the next video. Okay, let's take a look at the primary mirror. First of all, let me quickly go through how this is working. So you've got your telescope. And you have your main parts, which is the eyepiece, which you look through. You have your secondary mirror, and you have your primary mirror here. Now, as I said before, there's something called a focal length or vocal length. Okay, and it comes out like this, and then it gets rebounded through the eyepiece. But for this to work efficiently, these two mirrors need to be perfectly aligned. So that's what we're going to look at today. So essentially, you've got your primary mirror, like this, and what I'm planning on doing is having it placed on a plastic plate made out of HDP or something like that. I'll have to look it up later on, but it's a type of hard plastic. And I'm gonna have these holding the mirror in place in 3 positions on either side, okay, on this plate. At the bottom of the plate, you're gonna have some bolts going through on either corner, 3 bolts with a heavy duty spring. Okay, and then there's going to be a separate larger plate and the bolt extends all the way through the plate, and you'll have what's called like a knob screw here and here and here, and as you turn these knob screws, you'll be able to basically change the angle of the mirror, yeah, to get it to align with the actual secondary mirror. So when you look through the eyepiece, everything will be in line, and you should get a good view. If you don't get this aligned up, then you're probably going to get a distorted image. So that's really important. There's actually devices that you put inside the eyepiece, and it fires a laser down, and you can laser align everything. I think it's called collimating or something like that. But there's the bolts. Okay, so if you can imagine, this bolt will go through this plate. On the other side there'll be a washer, okay, right there. And then you got your spring, okay, and then this section here goes through this plate here. Okay, so you'll have another washer here, and it go through there. Sorry, it's this way around. Yeah, so if you imagine, the bolts come through here, goes through this washer, then there's the spring, there's another washer, then there's the plate. Okay, so there's a plate there, and then you got your knob screw, screws on. Okay, then as you squeeze it, it will constrict and move the angle of the mirror inside the actual telescope. So you could basically move this around. So this whole section here will go at the end of the telescope, inside it, and you'll have some goes all the way through, and then you'll have screws here and here and here, just holding it in place on the end of the tube. So that's essentially how it's going to work. Okay, here we can see the actual primary mirror. It's a 10-inch parabolic mirror, 1470 millimeters of focal length. And here you can see me positioning where the plates are going to be cut out of the HDP plastic plate. And I'm just playing around with the positioning for the springs and the adjustable knobs to adjust the angle of the primary mirror. Okay, so let's talk about the actual secondary mirror and how I'm going to get it done. I was thinking of using like a threaded, an aluminium rod, and I'm going to turn it down on my lathe to get the right diameter. But essentially what you're going to have is a section which is cut like this. Okay, and you'll have a base like this, and obviously this is going to be round. Okay, so you'll have a screw here and a screw here and a screw here, and obviously adjusting these screws will tilt this section here, which will hold the secondary mirror. The secondary mirror is going to be siliconed into position. And when you have your telescope, this will essentially just sit at the front of the telescope like this. Okay, and it's going to be held in place with these threaded rods, and your eyepiece will be here, just like in the picture at the beginning, and you'll look through and you'll see this. But this has to be able to move, you know, you've got to be able to tilt it, and that's why we're going to have these screws here, which will allow you to adjust the angle of the actual mirror. Let me just show you the actual aluminium rod that I'm going to use. Okay, I've gone ahead and I've cut this at 45 degrees, and that's going to be the section that's going to hold the actual primary mirror in position, sorry, the secondary mirror in position. And all I need to do here is cut this from here, then have another section here, okay, to make that. And I'll show you as I go along. So here I'm using a angled piece of paper to get that 45 degrees angle that I need, and I went ahead and basically cut it at 45 degrees, put it in the lathe, and I've turned it down. I think I turned it down to about 30 or 40 millimeters in diameter. I wanted to make the aluminium as light as possible, so I took some materials off of it, and I cut these grooves into the face where the mirror is going to be glued on with silicone, so the silicone's got something to grab onto. Looks cool too. Here you can see me taking out more material from the aluminium because I wanted it to be as light as possible. Let's see how it all gets put together. So here we can see the actual spider attached to the mirror. If you look all the way down there, you can see the 8-inch mirror all the way at the far end there. I went and sprayed the inside of the mirror, the inside of the tube matte black, and I also removed all the cardboard. The cardboard was just coming apart and it was peeling, so I ended up removing it. There was no need to have the cardboard on there anymore. And it also made the tube a lot lighter. Here you can see the spider, you can see the secondary mirror stuck to it. I used Evo stick. There's a glue that Evo stick make that's called stick like shit, so that's what I used to stick the mirror, and it's really strong. Worked out really well. I've got a viewfinder on the top there, which is 8x50. We have the 2-inch focuser, and I also use these knob screws here to cover up the ends of the M3 rods that I used for the spider. You can see these rods here which I've sprayed black and they go all the way across. I've actually used 3 rods and it works really well. I thought the mirror was going to be too big, but it actually worked really well. Now, I use this mirror on the top of my, I use this telescope on the top of my roof, and I was able to zoom into a building that was 5.7 miles away. And when you looked through the eyepiece, it basically looked like the building was 10 meters away. So, chance to look at the moon, unfortunately, because it wasn't in a position in the sky that I could view it from my property. So, you know, I'll just have to wait until that comes into line. Let's go to the back of the scope and take a look at the adjustment screws for the primary mirror. Okay, so this is the back of the telescope. These are the knobs which you use to tilt the mirror to adjust the angle of the primary mirror. This back plate here is made out of HDPE, which is a type of plastic. It's really good because it's strong, it doesn't flex much, and it's lightweight, and the back primary mirror is also stuck to that. So overall, I'm pretty happy with the way the sculpt looks. It's got a few high points here and there, but you know, I don't mind that. It worked really well. So I'm sure you're all dying to see some photos that I took with the actual telescope and what it could do. So here you go. You can see it works really well, and you could zoom in. You could zoom in really good actually. I was surprised and I was really happy with the outcome. So I went ahead and I finished off the telescope. It worked really well. The tripod was no good. It didn't work. It basically couldn't take the weight of the telescope. So I'm going to end up buying another heavy duty telescope which is motorized, that would allow me to actually track stars. I did buy a camera to use so I could basically try and get you guys an image, but without it being a tracking mount, without having a tracking mount, I couldn't track the stars, or I couldn't get a picture. For anyone that hasn't used a telescope before to look at stars, it's not as easy as it looks, because you basically align the star up, you look through your eyepiece, and then you look away for 1 minute, and suddenly the stars disappeared because the Earth is spinning. And the stars basically just keep moving, so it's really difficult to get a picture without having a motorized mount. So that's going to be the next thing I invest in. Now, originally when I set out to buy the reflective mirrors for the scope, I chose a mirror that had 800 millimeters focal point, but a length of 800 millimeters. But the one that I received was 750. Now that meant that my telescope was classed as what's called a fast scope, so it lets in lots of light. Unfortunately, it was taking in so much light that I was getting what's called coma, and that's basically when you get like a glare on the image. So you're looking at a star and then there's lots of light sort of bouncing off of it, and there's a glare and it's not very clear, so it's not a nice round bright star. So the correction for that would be to buy a coma corrector. Now I was looking at the price of those, and they're about between 80 to 300 pound. So I thought, well, if I'm going to spend that much, let me see if I can buy another mirror. And lo and behold, I looked on eBay and somebody was selling a 10-inch reflector mirror which had a focal point of 1200. So what I'm going to do is get this new mirror, and I'm going to start again. I'm going to go and build an even bigger telescope this time, and I will use a motorized mount, and I will try and get you guys some images of the stars or the moon or whatever I can find once this telescope's actually built. But if you want to see what the telescope looks like, hold on and I'll show you. So here you can actually see the telescope that I built, and I bought an Orion computerized go-to mount as well. I still haven't learned how to use it, but I pretty much built the tube exactly the same way as I built the old one. And you can see that it's almost twice the size of the old one, and it's got twice the magnification. So I could go up to about 500 times magnification with this particular telescope. Here you can see the tube, which I basically use heat shrink rather than painting it. It's the same sort of heat shrink that you would use on lithium batteries, believe it or not. I just bought that from eBay, and here you can see it just being tested on the motorized mount. I'll put up some pictures for you to guys see. Here you can see a video taken with my mobile phone for a 40mm eyepiece. It's during the day, just to give you guys an idea. In the next clip you can see a photo I took with my mobile phone. It's been cropped with a 40mm eyepiece, so if you like the video, please like and subscribe.